Hello, everyone. Welcome back to our show, Tech Talk with Amit and Rinat. Today, we are going to talk about artificial intelligence or AI, and Rinat Malik is going to help us understand the topic more. So, I will quickly pass it to Rinat.
Thank you, Amit. So yes, artificial intelligence is one of the hot topics, one of the cutting edge technologies that we are all talking about nowadays. And it is, the forecast is that this is going to take over a lot of the technological solutions, and we're already seeing artificial intelligence solutions in many places, in business organizations as well as in our daily lives as well. In Google, Amazon, everyone's using AI. But we all talk about it, and whenever there is a new project starting, we always, anything to do with IT projects, there's always this question that is, does it have AI? But a lot of the times we don't actually fully know or fully grasp what exactly is AI and what is the power of, how powerful it is, what it can do, and also what it can't do. So I thought this would be a really good topic to cover in our TED Talk, in our Tech Talk, especially for people who are who are within the organization making business decisions based on technical features. They need to fully understand what AI is and what it can do and where it can go in future, so they can make an informed decision. So based on all of that, and also a lot of confusion that is going around, while people are talking, I thought this would be a really good topic for us to talk about. For me, I have learned about AI when I went to uni to do a postgraduate diploma. I had academic knowledge from that degree, as well as also I was very interested in the whole topic. So I did further research. I've done some AI projects, and my career is in robotic process automation. So a lot of the times what I did is I've integrated AI solutions with robotic solutions, so they both work together to create a more holistic sort of technological output that is helpful and that is usable by different organizations. So from that perspective, I have some experience and a lot of knowledge around the subject. So that's why I wanted to talk about this today.
Sure, Renat. Thanks a lot for that quick introduction, and I hope our viewers can learn more by the end of this talk. So, guys, it's a quick shout out. If you like the talk that we are hosting, subs would be great, and we will quickly get on to the topic. So, artificial intelligence, as Renat said, is a very hot topic. The top companies like Google, Facebook, Amazon, everyone is actually experimenting with AI and its applications. And there are various aspects of artificial intelligence that everyone is exploring. But let's start with the beginning. Artificial intelligence. So artificial stands for something that is man-made, and intelligence is something that we all have but needs to be defined for a machine. So let's ask Rinad, what actually is artificial intelligence and how is it different from, say, human intelligence?
Yes, of course. So when we want to talk about artificial intelligence, first we want to define the terms. So as you mentioned, rightly so, Amit, that it's artificial and it's intelligence. But what do we actually mean by intelligence? I mean, we all know that we have some degree of intelligence within all of us, but what exactly is it, and what is the definition of it? So the way I put intelligence is that the ability to absorb knowledge and then create an output from that knowledge which was not there before. Somehow using the knowledge you can absorb and then create an output to solve a problem, if you like. Now, when we talk about artificial intelligence, we talk about the intelligence that we have made. It's not organic intelligence, which is as opposed to artificial intelligence. Organic intelligence is what we have, as humans, and also various other animals as well. And then as humans, we have something called general intelligence, which is when we use our consciousness to solve a problem, or when we're consciously aware of the whole context around us and understand what is going on. So artificial intelligence, which is the other side of this coin, which is uh, intelligence that is created by humans, which is in a way synthetic. In terms of intelligence, as we said, like as humans as well, we absorb knowledge with all our five senses.
Yes.
From the day we are born, we are absorbing knowledge, memorizing them, and then using that knowledge or that information, absorption of information, we are being able to forecast what will happen. We see something moving, we can sort of forecast where it's going, or using that knowledge, we could put those knowledges together, or the experiences together, and then come to a solution of a problem that we see. For example,
Yes.
after we're born, if we are hungry, we see that, this is food, and, if we consume it, it will help us with our hunger. When we see fire and we try to touch it, and then we learn that it is painful, so we shouldn't do that anymore. So
Yes.
that's the using of information, and then using that information to sort of navigate in future in a way that will either help us survive or solve a problem that we face in future. So with artificial intelligence, this is the same sort of idea. So the first thing it has to do is it has to learn it. So that's why we get this term machine learning quite often, tied
Yes.
in with whenever we talk about artificial intelligence, we always talk about machine learning. So a machine that can learn using the information that is provided to it, and then use it to solve a particular problem. That's what is what in current days, in nowadays, artificial intelligence is called. Now, I want to go back a little bit and say that I want to go as far as to say that there is some intelligence built into quite basic devices that we have been using for a long time as well. For example, when we have to make large, addition or subtraction or large maths, there is calculator which can do it
Yes.
faster than humans. So in one way, calculator is more intelligent than humans because it can do complex calculations faster. But that doesn't necessarily mean that in every aspect of intelligence, calculator is superior. Obviously, it's not. But we have to sort of we have to understand and acknowledge that there is some intelligence built into a lot of everyday products as well. But when we, that's why it's important to define what kind of intelligence it is that we're talking about. So, from back in the days, from long time ago, we have calculator, and then we have, technology evolved, we have computer, we have Excel, we have various computer applications which can do many things, many specific things that it's designed for. It can do a lot better than humans. But where the limitation comes in is that it's only this it can only do the things that it's designed for, specifically designed for, whereas human can sort of look around, understand the context of the situation, and realize what it is that is the most appropriate thing to do. For example, we have artificial intelligence artificial intelligent chess player which can beat the world champions. But if it is playing chess with a 10-year-old child, and for some reason, if one of the the king kind of topples over because the board was shaked a little bit, will have no idea that the next course of action should be to go and pick up that king and put it back where it was. Whereas a 10-year-old kid would have that understanding that, look, I know we're playing a game, but right now, in order to proceed with the game, the next course of action should be to put back the piece that fell over. So that's the general intelligence, that is the contextual understanding that the human has, which artificial intelligence doesn't have yet. But that's the path to get there is where one of the important steps to get there from calculator or from the regular computing to general intelligence is where we are. We're at the midpoint of it, where we use different algorithms which are designed to learn and then absorb that information and then use that information to create something that wasn't there before. So that's the biggest step up that is happening, and that's what we currently mean when we talk about artificial intelligence. So when we, as you said, I think I went into a bit more detail when you talking about artificial intelligence, but starting from something like calculator or a chess player, we then slowly moving on and progressing on to an artificial intelligence solution where it can take information, learn from it, and then create something new. So create a solution that wasn't there before. So that's something that is new. That's something a calculator can't do, Microsoft Excel can't do. But this is the part where it's really taking shape and to moving into real contextual intelligence. So these are the solutions that currently exist, and this is how do these solutions work, and what it can do are what I want to talk about today.
Okay, so I think thank you so much, Rinat, for this, quick explanation and the difference between artificial intelligence and human intelligence. So from what I can understand is human beings learn through observation and through their senses. So they have their environment, and using their senses, they absorb the information, and then they try to move in their environment by predicting based on the information that they already have. And
Yeah,
similarly, machines or computers, they absorb information through some algorithms you mentioned, and these algorithms get the information and they try to predict what is going to happen without any human input. So I think this is, correct me if I'm wrong, but this is what I understand so far.
yeah.
And then what you will, I think what I'm interested now is, how do you actually teach a machine to behave like a human or think like a human? Because you're right, a child would know when to pick up the piece on a chessboard, but how do we teach a computer to do the same thing when it observes this same behavior? So this is kind of interesting. So first I want to talk a bit more about the algorithms, and then we'll get into more details.
So when we talk about artificial intelligence, there are various algorithms that help us create these solutions. And one of the algorithms that is one of my favorite algorithm actually is called genetic algorithm. And this algorithm is based on natural selection. It's inspired from the theory of evolution and how in natural selection you start with a a overall random population, and then because overall after years and years after running and generation, it learns and mutates and keeps the best trait to survive. And then after millions of years and many iteration, it creates something that is perfect for the situation. And for example, if as humans evolved, we needed, we as human evolved, we faced different difficulties in our journey of evolution, and then through generations we learned a little bit, and then our best trait kept moving forward, and that's how we kept our best, and that's how we kept improving, and then we ended up where we are today. So this is the whole idea of genetic algorithm. There are other algorithms. One of the very popular one is artificial neural network, which is one of the main ones that we currently talk about and is being very heavily used in the world today by many organizations. But genetic algorithm is also a very powerful algorithm, which is also used in many places. Usually what happens is, for a very complex AI solution, we combine both artificial neural network and genetic algorithm and then create a very powerful AI solution from it. But yeah, there are various algorithms. What I really want to focus on today is the genetic algorithm, which is a very powerful algorithm in my opinion.
Okay. So thank you so much. I think genetic algorithm, yes, I've heard the word genetic from Charles Darwin's Theory of Evolution book, and it talks about survival of the fittest, or survival, or the person that can the the cell that can adapt the
Yes.
most in the environment will survive. So I'm guessing this is what it is in terms of what the algorithm is. So can you explain a bit more about genetic algorithm then?
Yes, absolutely. So, yeah, I mean, what you explained is exactly right. I mean, that is what genetic algorithm is all about. It goes through generations and then keeps the best trait to for the problem at hand, and then adapt to the surrounding, and then comes out, after many iteration, it comes up with a solution that will work for it to survive or for it to go past the problem. It is designed from an evolutionary perspective. um, so it starts with a randomly generated population, and then we the way we teach it is by giving it a problem and asking it to solve it. And if out of those 20, for example, it doesn't have to be 20, out of those number of randomly generated solutions, whichever one does the best, we rank them, and we take, say for example, the best ones, and then say if we say, for example, from 20 we take the best 5, and then create sort of combine the features of those best 5, and then take the best traits of them, and then create another 20, and then put them into test again, and then maybe they do a little bit better, but we keep taking the best 5 and then combine the features again and again, and then this is how the iteration keeps happening. And then the more iteration happens, I mean, one of the limitation, I suppose, with genetic algorithm is that it takes a lot of learning, a lot of iterations has to happen for it to slowly evolve and come up with a solution that wasn't there before. But the beauty of genetic algorithm is that it can come up with a solution that as humans we've never thought of, because it will randomly mutate. You add some mutation, say for example 2% mutation. So you take the best 5 performing samples and then combine all the features and create 20 new samples, but also you add like 5% randomness into it. So it does something very random out of the next, in the next generation. There's like 5% some very random things added, but also the best features are still kept. So as a result, what happens is, over time, over many iterations, thousands and thousands, and some powerful AI solutions have millions and millions of iterations, and then it brings up something completely new, which we haven't, even as a human, we haven't even thought of, even though we gave it a problem that as humans we can, because we created the whole scenario, we might know what the ultimate solution is. But then a lot of the times we became surprised that, the AI came up with such a elegant solution that we didn't even think of as humans. So that's the beauty of genetic algorithm, as opposed to other algorithms like artificial neural network, which just looks for pattern, good for pattern recognition. But genetic algorithm is really good at a problem that you don't know. If we give it a problem that even humans don't know a solution of, if it keeps going, if it keeps going through the generation, it will eventually come up with something that is beyond what we've all thought of. So that's how artificial intelligence can be very powerful to create solutions that currently don't even exist.
Interesting. I mean, to come up with solutions that even humans can't think about, I think that's quite powerful. So you said the genetic algorithm takes sample, and then with every iteration you add some randomness. So that's an algorithm, and I think some humans are behind those algorithms. So an algorithm is written in a way to change or learn from the previous iteration. So
Yes.
that's genetic algorithm. But then we also keep hearing about deep learning, machine learning. So is there any difference between the algorithm and learning? And if yes, then what is exactly? Because are you are the machines learning from machine learning, or are they learning it from the algorithm? So is there an algorithm to machine learning as well? So I mean, there are so many terms that keeps floating around. So can you help us understand the difference, if there is any?
Yes, yes, no problem at all. So it's actually a very interesting topic, and I know we set out to start talk. We set out to talk about algorithms, but this is something actually very interesting to know. So there are, whenever there is a problem, you could approach that problem in two ways. One is with an algorithm, and the other is with heuristic in a heuristic way. So to give an example, for example, if you go to a sort of to go grocery shopping to buy milk, for example, to a grocery shop. So now you don't know in which aisle exactly the milk is. Now, you can go by an algorithm, which gives you a guarantee that you will definitely find the milk. The algorithm, what it does is you start from either the left-hand side of the aisle, and then you go and check each aisle one by one until you find the milk. So that way you're guaranteed that you will find what you're looking for, but it may take a very long time because you may have started from the leftmost aisle, but the milk may have been in the last aisle that you're going to look for.
True.
So it will take longer, but you know that you will eventually find the milk. The heuristic method, on the other hand, is that using the information you already have and making a prediction, best judgment or best guess, and going to that aisle. So say for example, milk is usually chilled in a chilled section. So if you, instead of going aisle by aisle, if you just go to the chilled section first and see, oh, do they have milk here? And then you go and check, oh no, the first one is dessert. And then you go back and start again and think that, okay, milk is a dairy product, it might be with other dairy products, and then you go to the dairy aisle, and then you see. So that's like based on the information you have and trying to make something, might make a best guess, and then trying to get to your solution. Now it could be quicker because you are using some information, you're trying to not go past aisle by aisle, but it could also be for some bizarre reason if the milk is kept in a place which is not which is not in dairy, not in chilled section, and if it is for some reason, if it is in a completely different aisle, which the information you have doesn't take you there, then you're not going to end up finding the milk. So these are the two ways of solving problems. And
Interesting.
algorithm is so 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 the way algorithm is good, they're both good. They're both, both of these ways are good, and you apply them based on your current situation. But the way we apply algorithm is when we have a step-by-step guide, that these are the series of action we're going to take, and this is going to generate us a result.
Okay.
So when we talk about AI algorithms, we also have an understanding that these are the series of things we're going to do, and based on that, we can expect certain outcome. This is not the artificial intelligence steps, by the way. This is designing the artificial intelligence. That's the step. So for example, for genetic algorithm, we are going to take a number of steps. We're going to create a randomly generated population of, say, 20 samples, and then we are going to put it to test, step 2, and then we're going to record the results of each samples, step 3, and then we are going to take the best 5, for best 5 or best however many, and then these are the steps that we're going to take. So that's how the genetic algorithm is designed. Now, when we talk about machine learning or learning, so every iteration we are making within this genetic algorithm, the machine is the artificial AI solution is becoming a little bit more capable, because
Yes.
it did a little bit better in one generation, and then we took the best solution from them and created more samples, so it did a little bit more better. So that is in a way that the machine is learning, or machine is becoming more and more capable over generations or over iterations. That's the machine learning in genetic algorithm. Uh, Artificial neural network is the other one, which is also a very popular algorithm when we're talking about AI. Artificial intelligence, so ANN in short, it has various sort of levels where it sort of assesses the data and then does the digital calculation inside before it creates an output. So the number of levels it has when when a solution is sort of structured, that has an effect on how quickly it learns and how precise precise or how accurate the result is. And that is to do with deep learning. So deep learning is to do with more with artificial neural network, not to do with genetic algorithm. But how deep the levels are is what is reflection of how is what deep learning is. So if it has a lot of depth, then it has a nuanced, more detailed, very precise calculation, and it can learn quickly, and it can also come up with more precise output, precise results. So that's what deep learning is all about. But yeah, I mean, I totally understand where you're coming from. There's so many terms that are going on, and when we talk about machine learning, who is actually learning, how it is actually learning. So in the case of genetic algorithm, the learning can be said as the more iteration is happening. So it's not humans who are teaching it. We are also, when the iteration happens, we also create another software or another program which will basically record the results of each generation, and then give the feedback back to the AI solution, so it can take the best 5 and then create the next generation. So if we had to teach it every iteration, millions and millions of iterations, then we would be back to square one, because as humans it would take us years to teach an AI solution, and that's obviously not practical. So yeah, I mean, in this case, we just create another software which does the repetitive task of teaching, and once it has, once it is trained to solve that particular problem, then it is very powerful. It has become very capable. It has the right understanding of what kind of solution is necessary, and then it can be used to generate those outputs as necessary.
Interesting, very interesting. I mean, so you have deep learning using artificial neural network and you have machine learning using genetic algorithm. So can you use machine learning for artificial neural network and can you use deep learning for genetic algorithm as well?
Well, to be honest, so when we say machine learning, I mean, it is a very popular term.
Yes.
It is a, like a it's like a overall a generic term which is just to say that the machine is learning. So
Yes.
that could be used in both genetic algorithm and artificial neural network. Whenever it's being trained, they're trained in different ways, in different methods. But whenever they're being trained, they're being more capable. The more you train it, the more you give it sample data, the more it understands what it needs to do. So from that perspective, whenever you're training it, it's becoming more capable and it's learning and it's remembering what information is given to it. So that's the part. So machine learning is for both. Deep learning is to do with artificial neural network because it has the depth of when it creates the structure, a mesh structure that connects with each node to the other, that there is a depth to it. So that's what we call deep learning. But yeah, in genetic algorithm, we are more focused on generation based learning, where you learn from each iteration or each generation and become better the next generation.
Interesting, interesting. So, from what I understand, again, that deep learning is more specific to artificial neural networks or ANN, and maybe we can cover that in a different topic. But let's focus on genetic algorithms. So, you mentioned genetic algorithms, and we use machines to learn over every iteration or generation. So now when the machines are learning, so suppose there are 100 cat images that we keep
Yeah.
seeing in YouTube videos. So there are a lot of 100 cat images, and there are some blueberries in some cupcakes or muffins that are mixed in the cat images with their eyes. That's a very common example that I keep seeing when I Google about all this. So you have 100 images, say 90 are cat images and 10 are muffins with the blueberries. And the algorithm runs, and then as a human being, you tell it uh, uh, that if you have identified it as cat, it's correct. If you have identified it as muffin, it is correct. But if you have identified a cat as a muffin, then it's wrong. Or if you have identified a muffin as a cat, then it's wrong. So that is something that humans tell the algorithm. But now you're saying machines are learning it themselves, because if humans sit and keep telling the machine what to learn, it's going to take a lot of time.
Yeah.
So now, how do you tell a machine what is right and what is wrong?
So actually, this part is actually done by humans.
Okay.
So there are big databases. I can't remember from off the top of my head, but there are some like open source projects where there are like millions and billions of pictures, which are all categorized and sort of identified with what the content of that picture is. So that part of initially identifying what is a picture of is actually done by humans, but
Okay.
that has been a like a massive open source project, or everyone all over the world has helped to do the project. I can't remember off the top of my head, but if I do remember, I'll put it for the listeners. I'll put it in the description link at the end. But yeah, so initially that information was actually contributed by millions of people all over the world, and then we have this big database, and we sort of point the AI solution to that database to go through and learn from it.
Okay.
Yeah.
Okay, interesting. So you have a database and you're learning from it. It's interesting. I mean, it's. I don't know if you've heard of password hacking, but there are multiple ways of attacking. So normally passwords are stored as encrypted hashes,
Yes.
and so suppose you have ABCDE password, you encrypt it and you get a hash. And if you encrypt ABCD 123, you get a different hash. So you can either brute force
Yeah.
And brute force is like going through every single possible combination and guess the password. Or you get the hash, you calculate them in advance for every particular combination of alphabets and numbers. And if you get a hash for a particular user input, say the hash is this, and then if you in the table, it's called rainbow tables, and if you match the hash, you get the unencrypted value, and you can get the you can log in and you can hack into a user account. So this sounds something similar in ways how machines are learning.
Yes, yes, I've heard of rainbow tables before. It's a very interesting concept. But yeah, I mean, I don't know if it's exactly the same, but there is definitely some sort of similarity there. Yeah.
Some sort of similarity. Okay, that's good. So we've talked about genetic algorithm and the generations and everything, but then can you give us a practical example of where genetic algorithm is actually being used? I mean, you've mentioned about machines learning and then identifying all these images. There are databases. So what could be a practical example in a general day-to-day life where genetic algorithms can be used to solve problems that humans can't solve?
Yes, so one of the, I mean, so you know, when we talked about you know, recognizing the picture, recognizing the content of pictures, that's actually more of the artificial neural network used. But you can do that with genetic algorithm as well. But the main power of genetic algorithm is to do with something that we don't even know yet. You know, a solution. So one of the ways it can be used is to design, for example, a car or a motorbike.
Oh,
So,
interesting.
so for example, you create you know, you create a system, an AI solution, which where you say that, okay, make something which will have two wheels and some solid material, and that's all you tell it. And then it creates
Wow.
randomly generated, you know, say for example, you know, 50 shapes, which all of them will have two wheels and some randomly generated shape. And then it will create those 50, and then you say that, okay, you know, simulate, you know, running or driving through a terrain or through a road, and see how fast or how efficiently this, you know, piece of random, you know, two wheel some solid structure that you built, how far it can go. And then you put simulate all 50 of them, and then whichever goes the furthest, or whichever the top five goes the furthest, you take the shape or the structure of those top five, and then you mix and match those and then create the next generation. So the next 50 would be a little bit better because you created them with the best ones from the previous generation. And then you keep iterating it, and then you end up with a design that would go through various terrains, and you know, would be very powerful, it will be very efficient. It will have like the, you know, if you know, when you tell it that it has to have some solid, if you actually give it some physical properties, then you know, it will create a design where the center of gravity is exactly in the right place. And you know, it will take into account all of these things without actually knowing about what the physical rules are. It will just keep trying, you know, after millions of iteration, it had tried everything it could be and came up with the best one, best performing one. And this example that I just explained is actually is actually available in a website, which is, you know, is a website where I've sort of stared at this website, you know, where the genetic algorithm, you know, iterated through to a, you know, really well designed car. um, and it was so interesting. I just stared at it as it slowly improved and improved. So I actually have the website as well. It's a bit of a it's not just a very simple one. So it's rednuht.org/genetic_cars_2. So if you, I'll put the link at in
Sure.
our episode as well at the end for the listeners to go and stare at it. And I'm sure everyone would be amazed to see how, how the whole thing works. It will start with a number of samples, and it will track and see which one is which ones are doing the best, and then it will create the next generation from what it learned from that experiment, and then it will keep doing it. And if you leave it running overnight, in your computer, and in the morning you will see, after, say, for example, thousands of iteration, you'll see that the design is just automatic, from this AI solution, from this algorithm. It had come up with a design that is, not only is it functional, but it also looks really cool as well. So that kind of tells us that our human intuition, what we think looks cool, usually comes from some sort of functional benefit as well. So yeah, that's a really interesting website to go to and see how genetic algorithm works. So that's one way. And then there is a very, very good practical application as well, is that the way humans walk. When we walk, this is we stand upright, we walk with two legs. Not a lot of animals in the world moves or navigates like the way we do. Humans have evolved for generations and millions of years, and this is the perfect solutions. After all of these attempts, after all the natural selection, this is the best we came up with. This is good for hunting, this is good for navigating around wherever we want to go, is less resource intensive. So this is a method of going around, which is really good. And if we can replicate this in actual physical robots, or if we can also create robotic solutions for people who are unable to walk, and if we want to create mechanical devices which will attach to the person's, say, amputated leg, and etc., so that would have a massive benefit. So you could create a genetic algorithm solution where you say that, okay, you will have these three parts attached to each other. One would be the thigh part, one would be the leg, and one would be the drumstick. And then sorry, not the drumstick. One with the thigh, one with the leg, and one with the foot. So if you tell it that you have these three solid objects connected to each other, and these are the weights of it, and you have two of them, and they're connected to each other with another solid, and you just try to and they can move in this certain way, and then give it 50, create 50 samples, randomly create 50 samples, and then iterate through until it starts to walk, and until it walks the fastest, and until it can run, until it can do. And then eventually you will end up with shapes which doesn't require the whole solid. It may require only the shell of a leg, or so that will give us understanding on how we can design a mechanical robot, or something that is made out of metal. But we don't need to use a lot of metal, because we already figured out that we don't need the whole solid piece, we just need the minimum piece for it to work. So that could be another practical example of using genetic algorithm. There are many examples of where genetic algorithm was used to solve problems, and it came up with solutions that humans didn't even think of. And if our listeners and viewers, if you just go on YouTube and just search genetic algorithm solutions, you will be amazed what kind of solutions, and you would be thrilled to see the solutions that the AI has generated. And it's all from this simple algorithm that we've been living for millions of years ourselves. The idea is very simple: evolution, natural selection. Keep trying, take the best results, mix that up again, and try again. and just keep iterating this thousands and millions of times, and then you come up with the solution. And that is all there is in genetic algorithm. It's not rocket science. It's actually very straightforward and easy to understand. I understand, obviously, it needs to be implemented by coding, which might require software developers, etc. But the core idea of AI, genetic algorithm, is actually not that complex, and it just brings up amazing results.
So, I mean, that is quite fascinating. I mean, designing a car and designing bipedal robots. That is very fascinating. I think I've seen some lot of robots that are trying to mimic how we humans walk, and it's actually quite a difficult problem because you have to balance the weight, balance the structure, find the right center of mass, center of gravity, and then if you have weight on top of those, then how do you balance? So I think that's a very interesting problem to solve. But moving forward, I mean, you have all these genetic algorithms and they are doing all these wonderful things, but then are we actually seeing some practical uses in our day-to-day life, or are there limitations to these algorithms at present, and because of which we can't see a practical application? I mean, you've given us examples, but is it something that has already happen that we humans can actually start using it in our day-to-day life? Say Google Assistant, who is trying to learn every time you talk, and every time you respond to its question. Is that using genetic algorithm? And if that is not the case, then are there actually limitations to genetic algorithms that is actually preventing us to use it in day-to-day applications?
Of course. So I mean, all the different algorithms are good for something, and they all have some sort of limitation. So something, one algorithm is good for this particular task, and the other one is good for another particular task. But
Okay.
what is happening right now in current world? We are experiencing in our day-to-day life a lot of AI solutions, maybe without even knowing it. For example, big
Okay.
tech companies like Amazon, like Google, Facebook, all of them are doing AI solutions, and a lot of them we don't even realize that we are being subjected to this. And what is also happening is, obviously from a as we're talking, we're obviously exploring algorithms one by one or whatever. But what's happening with these big techs, they're not, you don't have to limit yourself with only one algorithm. So when they're designing an AI solution, they're architecting a solution which combines number of algorithms. So there are
Interesting.
so there could be an architecture of an AI solution which has genetic algorithm, which has artificial neural network, um, combined. So one aspect of the solution might require a lot of iteration through improvement, and the other one might require pattern recognition from various data. So you know it goes through maybe genetic algorithm, and then it outputs something, and then that output is taken by the artificial neural network, and then it's outputting something else. Or it could be the other way
Okay.
around. Artificial neural network is outputting something, and the genetic algorithm is saying that, okay, no, this is not gonna be good enough for the next iteration, and then it's giving the feedback at the start, and then it's learning again. So usually it's combined, not just these two algorithms, there are many other algorithms as well. So it's a a complex structure of various of these things are creating a very 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 intelligent solution, if you'd like, and then we are being subject to it. So for example, obviously, one of the things that we hear a lot about nowadays is how these big companies are tracking us and taking our data, recording our data, and etc. But we are all concerned about that. We don't want our data to be taken or whatever. But what do they do with this data is the question. So how are they using this data? And they're using this data to create or teach these machines what is the best you know, teach about us, and so the machines can interact with us better. For example, all of these companies, one of the main source of revenue is ad, and if they can give us more targeted ads, which are uh, which are going to appeal to us in a way that we are going to do take an action or purchase something, then obviously that would generate their revenue. So they want all of our data, and then input it to an AI solution, and then the AI solution tries many times and then sees what actually works best, and then based on our personalized data, it then comes back with a very appealing advertisement, which is definitely going to work for us. I mean, obviously, because of all the regulations, they can't, they probably can't be as sophisticated as the technology will allow them to be. Because if I think if there was no restriction, it could be that the AI would generate an advertisement. I mean, right now we have like pre-generated advertisement that we all see, but with current technology, it's possible that knowing you as a person and what kind of things, what kind of music you like, what kind of color you like, and based on that, it could create a tailor-made advertisement just for you based on your mood. Maybe if it's showing you at the end of the workday, it will probably show you with a blue color, which is more calming, blue color in the background, and it could probably write the tagline or the things in a way that will make you remember that product more. So all of these things are possible. They don't happen right now because of, for good reason, for that data protection and restriction, etc. But AI can do that. So that's how powerful it can be. But yes, for example, when you go on Amazon, you purchase something, it also shows you like, oh, these are other things you might like. And you'll see that a lot of the times those things are actually something that you would be very interested in. And that's
Yes.
actually the working of an AI. When you go and watch a video in YouTube and you see the suggested videos on the right hand side, and a lot of the times it's very difficult to not click on some of them because they just speak to you so much. And that's also the working of an AI. Based on your history of the type of videos you've seen and all the other details it knows about you, it makes a decision where it curates a personalized list of videos for you, and that is very appealing for you to click. um, Similarly, there many big tech companies like Spotify, when they create a curated playlist for you, whenever you see that kind of things, um, uh, that's usually the working of an AI. There are more sophisticated chatbots as well, which will talk to you based on what you're saying. So these are some examples of AI. And then there is another side of it, which is also in practical use, which is computer vision, some call it, where human handwriting is designed for humans to understand. It's not digital. And it also doesn't look like digital. A lot of the times, different people have completely different handwriting. Um, but then, after iterations, when an artificial AI solution has seen like millions and billions of these handwritings, different ones, and was told that, okay, this squiggly line means 2 or 3, or this other letter, it creates and it learns, and it then can now understand quite accurately as well, human handwriting. So these are some of the practical applications that are currently in place right as we speak. And yeah, more exciting times are coming ahead as well as the AI
Wow.
solutions become more
That is
powerful.
that is actually quite interesting. And thank you so much, Renaz. I mean, I didn't know that there are so many AI tech that is already being used to sell us to target us with advertisements, especially with Gmail and Facebook and Amazon and YouTube and so many other things. And you mentioned about computer vision, about handwriting, and yeah, I think it's a very valid scenario. I mean, sometimes even I can't understand someone else's handwriting, so it's
Yes.
so if humans can't understand, it's very difficult for even machines to understand. So it's actually quite beneficial if they learn to identify text, and then maybe in the future, if we go to if we uncover something, um, uh, an archaeologist uncovers a site and they can just look at a language and they can decipher using AI, that would be quite cool. So,
Yes.
I mean, those are genetic algorithms, but sorry, not genetic algorithms, but applications to genetic algorithms. But when you mentioned about computer vision, something also popped in my head: the driverless cars, which use machine vision.
Yes.
Are they also using AI to solve the problem of driving on road without human beings?
Yes, yes, very much so. So just correcting, all the applications I said, those are not just genetic algorithm, but they're combination of,
Okay.
genetic and, but yeah, as you know, it's a very interesting topic, driverless cars. So, yeah, they're definitely using AI solutions. There are cameras all around the car, and it is taking pictures after pictures every second. I mean, obviously, a video is, a 30 FPS video is just a 30 picture in serial, right? So it's analyzing all of the pictures, and obviously we know currently that AI can look at a picture and understand the content inside it. So if it sees a truck, for example, or another vehicle in front of it, then it can identify, with an AI solution that what it is in front of, or a human being, for example. And then from that serialized picture, it can also identify whether this picture is getting bigger, which means that it's coming closer. And, I mean, what it uses is a lot more complicated than just it getting bigger,
Yes.
because I'm just giving like a simpler explanation, because they also have like what do you call it, the infrared sensors as well. So it senses if there is an object, or the type of the type of object, whether it's metal or organic object and things like that. It's a lot more sophisticated than what I'm explaining, but I'm just trying to keep it simple. So yeah, I mean, it definitely uses AI solutions to navigate around within a road. And machine vision, computer vision, it's kind of synonymous in that way. It's basically looking at pictures and identifying what is in that picture is the technology. And it's mainly actually based on artificial neural network, because that is specific for understanding patterns. So if it looks at million picture of cars, then it will know what a car looks like, and then it will remember it, and then go from there.
Okay. So, I mean, you've talked about AI, you have talked about intelligence, you have talked about the algorithms, machine learning, deep learning, and everything. And you also said in the beginning that you actually did a university course, and that's how you got introduced to this topic. So, if a regular user, whoever is watching or listening to this talk, wants to get to know a bit more about AI, what do they need to do? Do they need to do a course? Do they need to watch? Do they need to know about mathematics? Do they need to know about programming? What essential skill sets do they need to have to learn about AI?
Right. So the first thing I would recommend that they do is subscribe to this channel. So there will be
Yes.
more talks. I'll do a few more talks focusing more on artificial neural network and a few other algorithms as well. So that would be a first place to get some like overall understanding for non-tech people, to understand how it works in simple words, rather than technical jargon. But then there are, I mean, to be honest, before starting an actual course, there are many information videos out there already about, telling you about what AI is. One thing to be mindful of is that there are, a lot more videos or a lot more articles about, you know, just explaining the very basics of what AI is rather than actually going into a little bit more detail. Um, what I would say is not to be scared, because there, to understand the actual algorithm, you don't need really good math or computer programming, anything. You just you know need to, for example, genetic algorithm. It's as I explained, that is all there is. And obviously now digitizing that requires some software, programming knowledge, or similar. But to understand how AI works, and from there what kind of output to expect, and that doesn't require math or software development knowledge. So I would just sort of recommend just looking at this kind of informational videos first, and then looking at videos of where AI is already in action. For example, if you just search for genetic algorithm in YouTube, or the website that I've mentioned as well, so that these websites will give you a really good understanding of how the things are working, and what kind of output to expect. um, yeah, and then if if the if someone is still interested to actually implement or create a solution, there are many AI related websites, which actually lets you create AI solutions from their building blocks. So they have building blocks in their website, which you can connect with each other and then create a solution. What I'll do is I'll try to list a number of these websites in our description of this topic, so the viewers and listeners can go and check them out. But there are many websites which just lets you play with AI, various algorithms of AI within their web interface, so they don't have to install anything. You can just go and start playing, and it's really interesting. It's fascinating. I'm sure our listeners and viewers will enjoy it very much.
I'm sure, Rinat. I think it is quite a fascinating field, and as you said, a lot of people are talking about it. A lot of companies have already embraced it. They are implementing solutions. So it's a good time to learn this technology, especially during this pandemic, where
Yeah.
we are stuck at home in lockdown and we don't have anything to do. So I think it's a good time to learn about something new that might actually change the world, because who knows, AI can solve the problem of finding the next new vaccine for a
Yes.
new disease. So and we just have to train the model or the algorithm, and it might come up with solutions.
Yes,
it
absolutely. And
is
who
it
knows,
is
it could also do something preventative. So it could probably predict that when the next outbreak of this next new virus is going to be, like maybe in 2040 or whenever it was going to be, if we are more better prepared beforehand, then it doesn't even have to start. So yeah, there's so many things that can happen with AI.
interesting. So I think we have covered more or less everything that we wanted to talk about AI, genetic algorithms, and everything. I think one last question from my end would be for any person wanting to learn about AI again is why do they need to learn AI? Is it actually necessary to learn AI, or they can live without learning AI?
So I'll say the same thing, where if about learning anything, any cutting edge technology. So when 100 years ago, 100 or so years ago, when the Industrial Revolution happened, before that, everyone was in agriculture. They all knew how to do farming. But when after the Industrial Revolution, there was a lot of factories where different kind of work was needed, and people who learned how to work in factory quickly, they were the first ones who were the early adopters of this new technology at the time. And then they were the ones who could really reap the benefits of knowing how a factory works, became probably an engineer earlier, a troubleshooter. um, so there is always that benefit of learning the new technology, because that will take you, that will sort of be the transition towards the new life that is coming ahead. So yes, I mean, and then, if you didn't want to work in a factory, there were more, less and less farmers working, and more factory workers within a very few years. You don't need to learn AI to survive, but it will certainly ensure a more informed life, where you know what is happening with your data, when you're interacting with all the technologies, how you might be being manipulated or not. You have much more control, much more knowledge, and know how to use them. So definitely would strongly recommend knowing more, at least know how it works, what to expect, and what is the future looking like with AI.
And I think it was quite helpful to understand about AI, machine learning, artificial intelligence, and algorithms, genetic algorithm, artificial neural networks. I think it's a very broad topic, and you rightly said that we need more sessions to understand this in depth. But I think one last question that I wanted to ask in the end is: do actually people need to learn AI, or they can live without learning AI?
Um, People can certainly live without learning AI, but I would still advise to be aware of it. You don't have to learn AI, but be aware that it's there. It's in our lives right now. It's affecting our lives, and you don't have to learn AI. You don't have to use AI, but you should be aware of what it is and what it's doing around us. So yeah, if people can live a happy life without having to learn AI. But yeah, I would recommend to just be aware of it.
Okay, so thank you so much again, Rinat. So just to summarize to all our viewers and listeners, today we learned about what is AI, what is or artificial intelligence, the different algorithms, the artificial neural network, and the genetic algorithm. Then we learned a bit about machine learning and deep learning. Then we talked about a bit of the applications, and Rinat mentioned some websites where you can actually see genetic algorithms evolve from a given set of rules to derive something completely something that humans can't even imagine. So Rinat will post those links in the description for the video. And I think he gave us some practical applications as well, where actually we are currently experiencing AI even without our knowledge. So thank you so much again, Rinat. So I hope you guys are enjoying our talk that we are trying to post every week about some upcoming technology. So please do subscribe to our channel, and review, like, share, comment, anything that you want. And do also let us know if you like any technology that you want us to talk about. And if we are not able to talk about it ourselves, we are actually planning to invite a few guests who can actually talk about those topics. So that's it from us for this episode, and hope to see you next time. Thank you, everyone.
Thank you very much, guys. See you next time.